So what number is cat? The machine's layers multiply and add. None of that means anything applied to a word. We need words as numbers before the learner can touch language at all. Here's the idea that would pop up in common sense. Number the vocabulary. Cat is 1, dog is 2, pizza is 3, on through 50,000. Compact, simple, and quietly wrong, because the moment those labels enter arithmetic, they stop being labels. Numbers have order and distance, so this scheme is claiming that dog sits exactly halfway between cat and pizza. Average cat and pizza, and you get dog. We've smuggled in a number line that doesn't exist. Fine, remove the fake ordering. Give every word its own private dimension. Cat is 50,000 zeros with a single 1 in position 1. Dog, the same with the 1 in position 2. No word is between any others now. But look at what we bought. Every word is now exactly as far from every other word. Cat is precisely as distant from dog as it is from carburetor. We fixed the lie about order by installing a lie about similarity, and 50,000 numbers per word, all but one of them 0, is a lot of paper to say nothing on. So maybe similarity has to be put in deliberately. Give each word a short list of properties we choose. Is it an animal? Is it food? Is it alive? Cat and dog land close together. Pizza lands far away. Correct at last. But slow down, because we've seen this move before. A human deciding, in advance, which properties matter. This is episode 2 again, rule writing dressed as arithmetic. What dimensions separate elegant from graceful? You'd need thousands, and everyone caps a word's meaning at exactly what you thought to ask. We already know how that story ends. In fact, all 3 failures share one symptom. Somebody had to decide what the numbers mean. And we already own the cure for that. Episode 4's whole discovery was that deciding can be replaced by learning. So don't design the numbers. Make the machine earn them. Set up a small prediction task. Given a word, guess the words that tend to appear around it. Train a little network on millions of sentences and force it to squeeze each word through a short list of numbers, a few hundred, on the way. To predict neighbors well, the network has no choice but to give similar numbers to words that keep similar company. Then, and this is the strange part, throw the predictions away. The numbers it was forced to learn are the product. A linguist, by the way, had stated the underlying bet back in 1957. You shall know a word by the company it keeps. This just turns that sentence into an error to minimize. And what comes out is geometry. Each word is now a point in a space, and the space means things. Cat sits near dog, kitten nearby, carburetor far across the room. Nobody entered that. It precipitated out of the sentences. Then someone tried arithmetic. Take the point for king, subtract man, add woman, and the nearest word to where you land is queen. The direction from man to woman and the direction from king to queen turn out to be roughly the same arrow. This, by the way, actually happened. 2013, a small team at Google, a tool called Word2Vec, an experiment that looked too simple to matter. Before celebrating, let's find where it breaks. Try doctor minus man plus woman on those same trained numbers, and you tend to land near nurse. The machine isn't opining about medicine. It is faithfully reporting decades of text in which doctors were he. Learn not designed means you inherit whatever the text contains, and geometry doesn't launder its inputs. And there's a quieter crack. Each word gets exactly 1 point. The bank of a river and the bank holding your money. 1 point. Forced to be both, when everything since episode 2 has told us meaning shifts with context. A fixed point can't shift. Still, the foothold is real, meaning as position, similarity as distance. We keep that forever. What we don't yet have is a sentence. A bag of points, however well placed, no more contains dog bites man than a bag of words did. The machine has to read them in order and somehow hold what it's read. How?